Welcome to the Walton Pi. Today we're going to be talking about linear approximations. So the situations that we're going to want to use linear approximations are when we are trying to find the value of a function at a point close to another point that is easy to calculate. So sometimes you might run into situations where for example, you don't have a calculator and you're trying to figure out what's the value of this function, but you can't evaluate it directly because it's a very complicated function. But at a point very close to it, you can evaluate the function and you can find the derivative at that point. And so in these situations, we can use a linear approximation to find a tangent line to the function at a point where you can calculate the tangent line. And then we just evaluate the tangent point we care about, and that's going to be a good approximation for the value of the function for a point that is close to the point where we found the tangent line. So for a function, the linear approximation or the tangent line approximation can be written as f of a plus f prime of a times x minus a, where a is the point where we are finding the tangent line. And so this is our linearization of f of x. This formula for L of x, that is basically just the point slope form, where we know the point is a comma f of a, and then the slope is going to be f prime of a. This is just point slope form of that line. And so let's go through an example together. Let's try and find a linear approximation for f of x equals sine of 3 pi x minus x cubed plus 7 at x equals 3. So the reason we might want to do this is we might want to be able to figure out what is f of 3.1. We could do 3.1 cubed, we could do adding 7, but then sine of 3 times pi times 3.1, that's not going to be a nice number to try and calculate. And so that's why we might use a linear approximation to do that. So the first thing we need to do is we need to know what is f of 3 and what is f prime of 3. So f of 3 is just going to be plugging in 3 into that, and we get out negative 20. But then for f prime of 3, we need to know what is f prime of x. So f prime of x is going to be a 3 pi cosine of 3 pi x minus 3x squared, which when we plug in 3 gives us a negative 3 pi minus 27. If we plug all of that into our formula for our linearization of f, we get L of x is negative 20 plus negative 3 pi minus 27 times x minus 3. And so this is just plugging in f of 3 and f prime of 3 into our formula for the linearization of f, so just using the point slope form. And so then using our linearization or our linear approximation of f of x, we can use that to approximate f of x for values close to x equals 3. So if we were to look at L of 3.1, that gives us negative 23.64247 and so on, while the true value of f of 3.1 is negative 23.600 and so on. So these values are pretty close, and so that gives us a little bit of, this gives us an example of why we would care about the linearization or the linear approximations. It's so that we can be able to find the value of a function for values that are close to a value that's easy to calculate. And if we had tried like f of 3.01 or f of 3.001, those would have been even better approximations. I hope this video was helpful in understanding linear approximations. Please check out some of my other videos, and please like and subscribe so that I can continue to make these videos. Have a great day and good luck with the rest of your math.